Hello and welcome. In this video, we're going to be discussing how to solve a system of equations by using substitution. So what does it mean to solve a system? So if we look at the first equation, well, we actually graphed out all of the solutions to this equation in a previous video. The graph formed a line, and so every single point on that line, the x and y coordinates, were a solution to this equation. So this guy alone has an infinite number of solutions. Same thing with this guy. So if we graphed out the solutions, we'd find that we get a straight line again, and every single point on that line would be a solution point. So again, this guy all by itself has an infinite number of solutions. So when we're trying to solve a system, we're trying to find a point that's both a solution of this equation and a solution of this equation at the same time. So maybe the first equation, when we graph it out, looks something like that. And maybe the second equation, when we graph it out, looks something like that. What we're looking for here in particular is we're looking for that point where these two graphs meet each other, where they intersect each other. We're looking for an x and a y coordinate. And so our first step in doing this by using the substitution method is we're going to take one of our equations and we're going to solve them for either x or y. So what I'm looking for in particular is which equation looks like it's going to be the least amount of work for me to solve for x or y. Well, when I look at this top equation, notice that it's almost solved for y. All I would need to do in order to get y alone is get rid of this negative 3x. The other ones aren't going to be so easy, and if we solve for each one of those, we're going to get fractions. So to me, the most attractive one to solve for either x or y is going to be this first one. Okay, so I've written out that first step. We're going to solve one of the equations for x or for y. So we're taking this first equation and we're going to solve it for y. So to do that, we're going to add 3x to both sides. And that's it. So that first equation becomes y equals 3x plus 4. The second step is what we call the substitution step. So I've written out our second step, and then I've just rewritten the equation that we found in step 1. Then right below it, I wrote down the other equation that we haven't yet used, the second equation. So what we're going to do is we're going to use the first equation to help us solve the second one. In particular, what we found by solving for y is that y is equal to 3x plus 4. So what I'm going to do is I'm going to take that 3x plus 4 and I'm going to plug it in for y in the second equation. So here we go. We've got 3 times 3x plus 4 plus 7x equals negative 36. So again, I replaced that y with what it was equal to from what we found in the first equation, 3x plus 4. Okay, our last step then is, at least to find x, is to solve the equation that is left. So what you'll notice is that the equation that's left only has x's in it, doesn't have y's anymore. So we know how to solve an equation like that. So I've just rewritten our equation out down here. And then our first step for solving an equation like this is let's distribute this 3 through. So if we do that, we get 3 times 3x is 9x, 3 times 4 is 12, plus 7x equals negative 36. Let's combine our x terms, so we get 16x plus 12 equals negative 36. And then let's subtract 12 from both sides. That gives us 16x equals negative 48. Divide both sides by 16, and that gives us x equals negative 3. So what we just found is sort of like half of our solution. We found, if we kind of look back at the original graph that I sketched out, what we basically found is the x coordinate where our two lines meet. That's not good enough because I want to find not only the x-coordinate but the y-coordinate as well. So the last step in the process is we just want to find the y-coordinate where those two guys meet. So I'm going to box in at least what we found so far, and then step 4 is going to be to do another substitution to find our y-coordinate. So what I've done is I've just written out our step 4, so we want to substitute to find y, and then I've written down our two original equations, and then the equation that we found by solving this first one for y. So if I want to find y, well, I know the x value is -3, so what I can do is I can take that -3 and plug it in for x in any one of these three equations. The question is, which one should I use? Well, in my opinion, the nicest one to use is this guy, because I don't need to do any work to actually solve for y after I've plugged in the x value. So we're going to plug -3 in for x, and that gives us y equals 3 times -3 plus 4. And if we do the math, we get -9 plus 4, which means y equals -5. So that means my solution, I would want to write as a point, the x-coordinate is -3, the y-coordinate is -5. Okay, here's another one for you to try. Pause the video and then restart after you've given it a shot. So for this one, the really nice thing is it's already solved, the first equation's already solved for x. So what we can do right away is just take what they gave us, which is that x is equal to y minus 4, and I can plug that right into the second equation. If we do that, we get 2 times, and now I'm plugging y minus 4 in for x, plus 5y equals 41. And then if we distribute our 2 through, we get 2y minus 8 plus 5y equals 41. Combine our y's, we get 7y minus 8 equals 41. Add 8 to both sides. That gives us 7y equals 49. Divide both sides by 7. Gives us y equals 7. And again, that's half of our solution. So now I just need to find the x value. Well, if I go back to the original, I can plug y in either here or here, but this one is really nice because it's already solved for x. So we're going to take our x value, our y value, and plug it in here and find our x value. So we've got x equals y minus 4. And if I plug 7 in for y, we get x equals 3. And that means our solution, we would want to write again as an ordered pair. The x-coordinate is 3, the y-coordinate is 7.